Hello everybody, welcome to Unit 1 Chapter 3. In this chapter we're going to be covering input and output. We'll learn how to use manipulators to format output and how to perform file, input, and output. You can find the files that we're going to be covering on Canvas. They're listed under the course documents under CPP files. You're looking for file output example and file input example. And we're going to use these two examples when we're talking about file input and output. So obviously the learning objectives are to be able to use these manipulators that we're going to cover and also to perform file input and output. C++ provides some manipulators to format output. They're used with the insertion output operator. Remember, that's this guy. Let me get my laser pointer. That's this guy right here, right? They're used, well, there's two types of manipulators. There's the ones that need parameters, such as set precision, set width, set fill, and these are located in the IO manip header. Okay, and then there's also ones that don't require parameters, such as endline, fixed, scientific, show point, and left and right. And these are in the IO stream header file. So don't forget that if you need to use these, you need to include the appropriate header file, such as IO manip and IO stream. So we're going to be using IO stream a lot, so you don't really have to worry about that, but you might have to remember to include the IO manip. If you want a complete listing of all the manipulators that are out there, you can go to the c++.com site, and it's got all kinds of references for you. Okay? So let's start with the manipulators that are located in IO stream. And these ones don't require any parameters. So first there's the fixed or scientific outputs for floating point numbers, and it does exactly that. It outputs them in a fixed or scientific format. So if we have D, now D by itself would normally just print out 4, but if we give it the fixed format, it will specify that the decimals will be added. And this is similar to show point, which forces output to show decimals and leading zeros. But there's a slight difference between the two, and it gets into how floating point numbers are represented between scientific and fixed. Now, if you have fixed, or if you have show point, it will force there to be decimals no matter what. Okay. Then finally, we also have the left-right, which doesn't require any parameters. However, it's only used in conjunction with the set width of the IO manipulate library, and so you have to specify a width of a certain field, and then the left or right will justify it accordingly. So let's go ahead and take a look at some of these in codes. That way it's a little bit more clear on what's going on. Okay, so let's go ahead and take a look at these in use. I'm going to go ahead and run this, and then we'll walk through the code line by line. So here you can see we are declaring double D is equal to 4, and we're printing it out in default, and then we're outputting D with a new line. Okay, so here you can see that. Okay, printing default, and then we're printing 4. Then we print fixed, and we specify our output to be fixed, and then we're printing D with a new line. Okay, and you can see that right here. We're printing it out with 6 decimal places. Okay. And then we unset that setting. So this basically undoes this part right here. Okay. Then we go to print show point, and all show point does is it just forces a decimal no matter what. Even if it's an integer, it will go ahead and say, hey, you know, we're gonna print you. There's not a lot of difference between fixed and show point, but show point is based on whether or not that you actually have a decimal place. It gets into, there's a little bit slight difference between when you're showing scientifically formatted text and not, but most times you're just going to use fixed, so I wouldn't worry about show point all that much. If you really want to know, you can look it up and see how to use it. There's a lot of resources online. As far as the justification here, you can see we had to use the set width function. Okay, now that again is part of the IO manip library, but in order to show standard left and standard right, we had to set our width to 5, and you can see that here. This takes up 5 spaces, so you can see the 4 is left justified here, and you can see on the line below it you can see how 4 is right justified. Okay, so those are the basic usages of how you format text using the manipulators from IOStream. So now let's take a look at the manipulators that are included in IOmanip. And again, these are the ones that use parameters. So we will use 3 double values in our explanation, and cout prints at most 6 of these digits by default. So here 12.34567 is printed out as 12.3457. When we use set precision by itself, it will output the total number of digits that you pass in. So here you can see that we're setting the precision to 3, so D is printing as 4, E, which is 12.34567, is printing out as 12.3, and 5555 is being printed out as 5.56 times 10 to the third, right? So, but more often than not, set precision is used together with fixed to display exactly n digits after the decimal point. So you can see here that we are using, let me grab my laser pointer. You can see here that we are using fixed, and then we're saying it to set the precision, and now we're printing out the number of decimals after the decimal point. So our precision refers to the decimal point, not the entire length of the numbers itself. Okay, so that's how you use set precision by itself or in conjunction with fixed to achieve the formatting that you want. Excuse me, I got the hiccups. So now we looked at set width earlier when we were looking at the IOStream manipulators. But again, set width outputs a value of an expression in a specified number of columns, right? So if we had this code here, you can see that we're setting the width to 4, and so we're giving it 1, 2, 3 extra spaces, okay? And the value is right justified by default, and unused columns to the left are filled with spaces. Now, set fill allows you to specify a different character for filling the used columns. So here you can see that C is going to be the character that we pass in to fill the columns, right? So here we're calling set fill, and we're passing in the character pound, or hashtag for you millennials or younger folks. And then we're setting the width, and so here you can see that it filled in all the spaces with the pound symbol instead of the spaces. So how do we disable the manipulators after we've created them? Okay, well, set width you don't have to worry about because it only applies to the next item that you're printing out or you're putting into the output stream. Okay, so that this number or this space, I want it to be 20 characters, and then you print out whatever you are using the stream insertion operator, and then after that it goes back to normal. Okay, so you don't have to worry about that. Other manipulators, except for endline, they apply to the output stream object until the setting is changed or disabled. Okay, so these are the ones with parameters like set precision, and set fill. Okay, and again, those without parameters are endline, fixed, scientific, show point, and left and right in IOStream. Okay, again, set W does not require you to disable it. It's just showing you the manipulators that are in the 2 different libraries. Okay, so to disable a manipulator, you use the OStream member function unsetF, okay, and you pass in the constant that you want to change. And you're like, well, what is this iOS constant? What is this business right here? Okay, well, if you look at it, it looks like this. So you have standard cout, right, and then you're calling its member function unsetF, and you're passing in this constant. So this is a constant that refers to the fixed format. This is a constant that refers to the left format. Okay, and again, if you're having problems with this, you can always look up this online for more information on how to use these. We're not going to be spending a lot of time in class. Some of your homework you're going to have to format, so you do need to be comfortable with it, but just remember how to look it up. And this is one of those things that if you don't use it all the time, you're going to forget. But you just have to know the general mechanics of it, okay? Let's now turn our attention to file I/O. Now, file I/O is very similar to the standard input and output that we've already seen with the reading input from the user via the console and outputting it to the screen. There are a few small differences that we need to take a look at so you can understand how to do file I/O, but I think it'll be pretty intuitive once we get those changes out of the way. So let's talk about how we actually perform file input and output. And really you just need to follow this 5-step process. First, we need to include the file stream header. This is very similar to the IO stream header that we used previously for standard input and output with the keyboard and to the console. Okay. Next, we have to declare a file stream variable, a reference variable. This is automatically done for you with the IO stream. Remember, we use CIN and COUT. Well, now when we're working with file streams, we have to declare our own file stream variables. Once you do that, you then associate the file stream variable with the input or output source, i.e., what file do you want to open or write to, okay? And then next, we want to check to make sure that that open operation was actually successful, that there wasn't something going on behind the scenes with the operating system that prevented us from using that file. And it's always a good idea to do this before you do any type of processing with the file, so that way you make sure that before you go through a long list of trying to read in something and write out something else, that those things are actually available to use. Then we use the file stream variables that we declared up here, right, with our standard extraction and insertion operators, just like we did with the IO stream. And then finally, we close the file, okay? And that's it. These 5 steps are all there are to file I/O. And you did things very similar in Java. It might just be a little bit different looking, right? But we're going to go through some examples on how to do it. So here's the first example of how to do it, right? We're including our file stream operator, right? Or the header, excuse me. And then we are declaring our output file stream object. Okay, we're declaring a reference variable called outFile. And then we actually open a file. And this is that step 3 where we associate the file with our object. We're using the open method of the output file stream class to tell the OS what file we want to open. Okay, and that's it. That's steps 1 through 3. Very, very simple. And what does that look like? Well, when we actually run this program, it's going to create a file within the same directory where our CPP file was at, right? If the file doesn't already exist, it will create the file. If it does exist, it will overwrite the file unless you tell it to append it to the end of the file that already exists. And your textbook in chapter 3 tells you how to do this. It's using the append constant, but again, I'm not sure what page it's on, but it's in the textbook on how to go ahead and do that. And so we'll see some examples later on. So here you can see that when we run the program, which was this console application 1, I didn't bother giving it a good name, you can see the result here is our output text file that was opened up and created to allow us to write results to it. Now, obviously in the previous screen, we didn't actually do any manipulation with it. All we did was open it, but I just wanted to show you that it's going to reside within the same directory as your CPP file. So as I previously stated, it's very important to check to see if the open operation was actually successful. And it's also important to let the user know if it was or wasn't. So in our previous example, you can see here that we're just terminating the program after we open it, right? But what could go wrong with opening the file? Well, the program may not have the right permissions to the destination folder, so it can't create the file, or it could be already opened by another application, right? So there's lots of different reasons why file operations won't work. So we need to check to make sure that it's actually, you can. So how do you do that? Well, first, we simply call the .fail method of our output file stream object. So you can see that here. Let me get my laser pointer. You can see that right here. So this basically says if this fails, right, if we are unable to open the output file object, then we need to do something, right? Well, it's as simple as this. Hey, we're gonna send an output to our common error stream that we couldn't open up the file. Okay, and normally this standard C error is going to get redirected to the terminal anyway, but you can modify where that error stream goes, and so that's why you might want it logged, you might want to do different things with it. So that's why we put this fact that it's an error into the error stream and not just to the standard C out. Okay, but in a standard setup with the way that you're running your programs right now, this is going to show up in the console output just like a standard C out would. Okay, and then we want to return 1 saying that we didn't terminate the program normally. That's what the return 0 indicates, is that hey, we executed our program and it terminated normally. Return 1 states that we are terminating with an error. Okay. Now, if we are successful, we're not going to execute this block of code right here, and we're going to go on to the next bit, which is, hey, we're going to do an operation, okay? And here you can see that we're just doing a standard for loop from 0 to 9, and we're just going to output 0 to 9, right? Now, I will caution you, many people will output, or for a for loop, they will omit the braces if they're only doing one line. I suggest that you don't do this, because it becomes very easy to add things after that line and you forget to add the braces in, and then you get compiler errors, or you don't have compiler errors, but you have code that's not executing how you plan it to be. So I highly recommend that even for one line of code in a for loop, you still use your curly braces to, block that section of code off into the for loop. Okay? After we're done processing it, in this case we're just printing from 0 to 9, we close our file, which is step 5, and then we're done. We looked at how to output the contents of a program to a file, but how do we do the opposite? How do we read contents of a file into a program? Well, let's take a look at that. So again, first thing we need to do is we need to make sure that we are including the file stream header, right? So fstream, we included that, right? Next, we want to declare our variable, just like we did before for our output file stream, but now we're using an input file stream. So notice the difference here with our class that we are declaring. It's a input file stream object, okay? Then we want to associate our file with our object, and so we do that by calling the open method of the input file stream class on our object, and we pass in the file that we want to open. Okay. Next, we check to see if it was successful. Again, for the same reasons that apply for an output file. File might be already opened by another program, might be permission issues, number of different things, right? So if we can't open it, we report it to our standard C error, our common error stream, and let the user know, hey, this isn't working, right? And we terminate with a condition other than 0. Next, we perform our read operations, and we'll take a look at this in a minute. But for now, we're just going to do work, right? We're going to process the file. And then once we're all done processing the file, we go ahead and close it, okay? So the process is the same, whether it's input or output. You include the fstream, you declare your variable, you associate the variable with the class by calling .open, you check to make sure that it's successful with .fail, and then you do your work, whether it's reading or writing, and then you close it. And that's it. Okay, so how do we actually process the data? Well, say we have a file, our data.txt contains a list of names, okay? Like in this case, data contains Tom, Mary, Larry, and Ben, right? And we just want to, for this purpose, we just want to list the contents of the file in our program, right? We want to send it to the console. So how do we do that? Well, we're going to set it up in a loop to process each line, right? So here, and this is this is taken from our previous program here. This is step 4, right? We're going to declare a string, right? And then here's where the magic is, right? Right here. Here's where we actually do our processing. And you can see we've got our braces for our while loop, right? While we read our string from our file, while we extract our string from the file, we're going to output it to the console, okay? So what's happening here is this extraction operator will return true if the operation was successful. If it wasn't successful, it will return false, okay? So basically that means when we got to the end of the file and there is no more things to read, no more things to extract from the file, we will terminate our loop, right? And then when we're all finished, we simply close the file as we've already showed in the previous slide. So let's go ahead and take a look at how this actually runs in an IDE. So if I pop on over to my Visual Studio, you'll see that we have everything that was in the previous slide just put together in the actual file, right? We've got steps 1 through 3 here, where we declare our variables, do our imports, check to see if the file was opened correctly. We got section 4, which is process the file, right? We're just looping through it. And then we got our 5th step, which is close the file, right? So let's go ahead and run it. All right. And you can see, if I bring my console over here, you can see that we've got our names that were listed in the file. Okay. So if I close this window, right, we terminate the program. If I modify the contents of the file, and say Jack and April, right? Okay, we save that. And if we run it again, now you can see in our console, you can see that the new names are there, right? So proof that it works, okay? We can also, one thing I also wanted to show you was how to use your debugger. So say we wanted to loop through and we wanted to check to see what string was storing as we process through. Well, you can click over here in what's called the gutter and you can get a debug point or a breakpoint. That's the word I was looking for. Thank you. And if we run the debugger, you're going to find that it's going to stop every time right here. And so now you can look down at our local variables and we can see that we have this file in file. It has an object and it has all of its various attributes and properties that are associated with it. And on complex things, you know, this can be, you can be looking at this going, this is a bit overwhelming. There's a lot of stuff going on here. Okay, we're not going to worry about that for now, but if you just look at string, right, you can see that it's storing Tom, right, and its size is 3 because there's 3 letters in it, right? And you can see that it's just an array, and you can see that it's got each character is stored individually, T, O, and M, right? And you can see the ASCII value for it, okay? So if you look up here, you can see some various debug options where we can go to the next statement, we can step into, step over, and step out of. So what step into does is if you have a function that's being called, step into will go into that function in the debugger, and so you can walk through it. If you don't want to do that, because you can get into the weeds of some very low level stuff, what you're going to want to do is step over, which will just execute the function without going into it via the debugger. And then if you are deep into the weeds, if say you clicked on step into and then you wanted to get out of that function, you could just click step out of, right? So for now, we'll just click step over, right? And you can see we get to the end of the while loop and it goes back to the top and now we're back here. Now you can see that string is equal to Mary, okay? And you can pull up our console and you can see that we've read in string is now Mary, but we haven't output it to the console yet, right? So if we step over, now if we pull up the console again, you can see that Mary was outputted. So the debugger is extremely useful in figuring out what's going on with your program. If there's an error or there's a calculation that's going on, instead of typing out, let's print this out, the value of this thing is blah, you can just set a debug point and just look at the values as the program is running, okay? So I can't stress this enough. This is a skill that you absolutely need to develop, and know how to use the tools that are at your disposal. Now, we looked at how to do each step individually, but in reality, most times you're going to be processing in and out of a file or multiple files. So really the logical conclusion here is that you combine the things that we've looked at already. In this case, we need to make sure that we are declaring an output file object, right, and associated with whatever file we want, and that we check it to make sure that it's successful, right? And we do the same thing within the same program with our input file, right? So you have to do the step 3, 2 and 3, and 3.5 for both your inputs and your outputs, okay? Other than that, it's the same process, right? You're going to include your file streams, declare your variables, check them, make sure that they're good, process them whatever ways you need to depending on what your requirements are, okay? And then you close the files as soon as you're done with them. And that's it. That's all there is to file I/O. So, in summary, we use the output manipulators with the stream insertion operator, okay, to modify how we want numbers to look or to add, say, certain spacings to our output, so on and so forth, right? And then we looked at how we open up files for reading and writing using the 5-step file I/O process.